we talk about a little bit failures as well. All right, guys, we've waited enough. Let's start.
Rajesh at home.
Hey guys, now let's start today's proceeding. All right, so we're going to talk about performance optimization, guys. One of the key things, guys, in production, if you want to control the performance of your Kafka, you require to have this performance optimization. So, so Kafka performance tuning consists of two parts, guys. You might need to tune your Kafka for optimal performance, right? Or sometimes, guys, you have to do some set of configuration. So basically, production server configuration, you have to make it, right? So although, guys, there are many configurations available to optimize performance of Kafka, but we're going to discuss few important configurations which is required to set up that kind of a producer, consumer, or a broker. All right, so basically we're going to divide all this configuration, all right, into three parts: producer side, all right, consumer side, and broker side. So if I want to understand performance tuning, there are two major factors available, right? In any performance tuning of any application or any server. So let's open a. Right. So if I want to consider this performance optimization, so basically you have to take care of performance in between these two components, guys. One of the component is throughput. Right. And another component is latency. So basically, the first component is, if I'm talking about performance optimization, guys, always these are the two areas which you have to consider: latency, and the second one is throughput. Right. So bottom line, guys, in entire performance optimization, guys, you have to reduce latency, and you have to, yes, somebody has question.
Your screen is not shared, Pawan.
Oh, screen is not shared. Sorry. Now, are you guys able to see?
Yes, yes.
Super. So bottom line, guys, let me repeat: performance, any programming language or any software technology, if you consider, performance optimization is kind of like stands between these two parameters, all right, latency and throughput. So anytime, guys, if somebody say performance optimization, or what you have to do here is you have to reduce the latency or increase the throughput. Now, in my case, what is latency and what is throughput? All right, latency is nothing but time to carry. Latency means time. Anytime somebody say latency, that means it's a time delay kind of stuff. So if I want to read or write my data into Kafka broker, all right, if I want to fetch those information and process this data, so how much time is kind of like usually it is taking? How much time I'm reducing by making some of kind of like super configurations, right? That is nothing but latency, guys. So basically, you have to somehow you have to make your application to write or read your data from Kafka in a very faster rate. So that is kind of like, that's where like performance optimization comes into the picture. Now another important stack is throughput. So I want to read maximum data. All right, I want to read maximum data in parallel. All right, that is called throughput. So for every request, guys, I'm gonna get it in a bunch of data. So that is nothing but a throughput. So I have to increase this throughput and I have to reduce this latency. Now, you know that like where this performance optimization in Kafka, you can think about. All right, so either it can be a producer side. So how fast my producer is writing in Kafka. Second, we can think in broker side. So how my broker is accepting the data, how fast it is replicating, all right, how much latency it is taking, all right. So there is some performance optimization parameters available for producer, for broker, and the last one is nothing but your consumer. So these are the three areas, guys, which you have to think about the performance tuning. All right. Now, they are kind of like properties with respect to producer side. Let me show you. We have written our producer and consumer application, right? So I'm going to show you those properties. Now let's talk about like producer. What are the key things you can set it up? So inside producer configuration, guys, you got like some of the properties available like producer side of the configuration. All right. So the first important property, guys, compression. All right. As a name suggests a lot of things here, but we're going to talk about it. Second, very important here is, all right, by default, guys, Kafka will send you data record by record. All right. instead of that, guys, if I can create a buffer of, instead of that, if I can create a batches and store my data in the buffer, and then I'm going to make entire batch as kind of like one request, right? So if I can increase the bit of batch size, I can make kind of like more throughput, but at the cost of latency. So you have to select the optimal value. So basically, guys, synchronous mode and asynchronous mode, they are two options available. Now let's learn about this compression. So what is compression? So by default, guys, you know that your Kafka is going to store your data in a kind of like some kind of like byte format. Already, it is kind of like Kafka store your data in a binary serialized file format, or you can say it stores your data in serialized file format. So basically, inside Kafka, guys, there is nothing. It is just nothing but the storage of key value pair, and it is in binary format. Nobody can read it. That is the reason, guys, if you observe, when I write my producer application, I have serialized it using string serializer. Like that, all right, I can improve the performance of serialization by including serializers like Avro serializer, Thrift serializers. All right, there are external serialization framework available. That is one thing. Compression, guys. Compression is always very important role. Since you are dealing with the data, guys, you have to compress your data. So you know that, like, if you want to send a big file over the internet, guys, what you're gonna do, guys? What you're gonna do, guys? Imagine that I want to send a very big file to you. So what you're gonna do from your desktop, guys, you're gonna use Gunzip software or bzip software, and you're gonna zip that particular file. Then you're gonna upload in your server. You're gonna download it, and you're gonna unzip it. Yes, this is kind of like process you're gonna follow. Right, whenever I want to upload my data into some other cross-center platform, what I'm going to do here is I'm going to unzip my data, and I'm going to load my data across a network, and from there, somebody will download and consume and unzip it and consume my data, right? So this avoids, so if you compact your data, what's going to happen, guys? It's going to reduce the size, right? If it is reduced, if the size is reduced, it's going to take less time to travel across the network. So basically, one of the key optimization you can think about is compression. Now, I got so many other options. Let me write it. So I got like options for serialization. Everybody does have its own features. So based upon your company requirement, like what they needed, whether they want to split the file, or they want to distribute that particular file, or they are like other benefit factors available. I'm just listing it. So you just need to read about Snappy. You need to read about like Gunzip. You need to read about LZ4. All right. You need to read about bzip. All right. These are kind of like compression software available. Luckily, Kafka support also. So based upon your business requirement, or you have to read about this compression, what they offer, and if it is matching with your requirement, guys, all right, or if you don't know much about it, so whoever give you kind of like more compressed format, you can use that as your compression. Now, if I want to use compression in my producer or consumer code, what I have to do? So I'm going to start my Eclipse utility. All right. So guys, it's taking a bit time. Okay. So guys, I've opened here. Now, across your producer, guys, you can produce or you can add few more properties for optimization. So I'm adding compression properties. So I can set few properties like producer config, and you can see that I got one of the property called compression. So I'm going to use compression type config. This is a parameter name, and you can specify what compression you want to use. I've specified that. I'm very happy with Snappy. All right, it's going to compress your data much faster. So I'm going to use Snappy for my production environment. Right. So this is how you can specify your. This is how you can specify your compression. So we talk about compression. The next parameter, guys, we need to talk about. Right? We need to talk about the batch size. Now, what is the optimal batch size you're going to have? So as we know, what is the optimal batch size? So imagine that just now I've explained a graph. All right. So basically I got like x-axis and y-axis. All right. And if you observe, guys, this axis I'm going to consider as latency, and this axis, right, if I consider throughput. So you know that like if I want to increase throughput, guys, all right, I will get kind of like higher latency. All right, if I increase throughput, latency is increased. All right, if I decrease throughput, guys, latency will increase. So what you have to do here is you have to select optimal values between your latency latency and throughput. So you have to select the optimal value. You can pick over here or based upon throughput, guys, how much latency you can kind of like work out. All right. So I can choose that particular value. So basically you have to select, right, your batch size, optimal value. All right. So you know that like if you go increase throughput, guys, again, kind of like latency is gonna be kind of like increase. So based upon like what suited best, all right, what suited best, how much throughput you want and how much latency you're okay to work on it, guys. Based upon that, you're gonna specify the batch size. All right. So although it is kind of like always confusing that what batch size will you pick in production, all right? The optimal way to think about is, guys, all right, how much throughput you want. So we can say that like large batch size may great have high throughput, but guys, at the cost of latency, all right? So basically they are inversely proportional to each other as we have discussed. So you have to select a proper value according to it. All right. We know that the important measures for performance optimization is nothing but throughput and latency measures. All right. Now let's understand about this. Right. So we want to talk about batch size. So instead of number of messages, guys, to send your data to a Kafka, guys, what I'm gonna do here is I'm gonna get so a batch kind of stuff. So what I'm doing here is, let's understand. So instead of single message, guys, all right, and I'm sending my data to my Kafka broker. Rather than, guys, I'm creating a batch size across my producer. And I can write this as producer batch. Now, if you specify this value optimally, all right, so based upon your throughput and based upon timestamp, all right, you can control this. All right. So I can specify how many total bytes I can send. I can control this batch size by total bytes. Right. So this batch, all right, let's say that I have specified a batch of 1,000 bytes. Imagine that. So 1,000 bytes, it's going to collect all your requests here in buffer and it's going to collect 1,000 bytes. And then it's going to make a request to Mr. Kafka stating that, okay, I got a batch ready. I got a batch ready. Now you can store your batch data into your topic. All right. So the idea is, guys, I have to choose the byte size optimally. All right. So I cannot choose any bigger value, guys. So I cannot choose very bigger value. You know that like it is inversely proportional to the latency and all. So you cannot increase the, like you cannot specify beyond your memory also. So all your producer batches shouldn't be kind of like exceeding available memory. And the default value is, guys, 16384 bytes. All right. Right. Now, now, with respect to batch, guys, you got one very important property called linger.ms. So Kafka producer configuration, if you go, all right. So now if you go here down, so Bootstrap, buffer memory, right, compression type, right. So you got a property called linger.ms, guys, right? So you know that, all right, all my data is going to be batched, right? Producer is going to group together any record arrive in between request transmission as a single batch request. So I'm not going to send all my messages directly to my producer now. What I'm going to do here is I'm going to create a batches, all right? Normally this occur only load when record arrive faster than they can send out. So imagine that I got like too many records, I'm getting it, all right, and I'm not able to kind of like send to my data faster in my Kafka. So in this particular situation, guys, client wants to reduce number of requests, all right, or it wants to take kind of like moderate load. Now I got a property called linger.ms. This is also a timestamp property. So this setting accomplish what it's going to accomplish by adding small amount of artificial delay. Right? Some small amount of artificial delay kind of stuff I'm going to make. So basically, guys, all right, if your batch is kind of your batch is kind of like you have specified a batch and it is created a batch. Now the situation is, guys, you want to write that into a Kafka. It is writing in a slower rate. So what you're gonna do before creating a new batch, guys, what I can do here is I can specify some artificial delay to fill this particular batch. All right. If I specify 5, so it's gonna wait for 5 milliseconds. All right, to create a new batch. All right. So this is called linger.ms, guys. If you feel like in your Kafka, all right, record is like producer is writing more records in your batches rather than consuming stuff inside your Kafka broker, or rather than sending your data in Kafka broker. All right. So if producer rate is very fast, guys, you can kind of like delay his request by having a property called linger.ms. All right. If you want to specify this linger.ms or a batch size, guys, in Kafka, so again, I can add properties, set property. Right? I can specify producer config dot, right? I got linger ms config, right? And I can specify 5 milliseconds, right? 10 milliseconds I can specify. So this will not make sense, guys, if I not specify properties dot set property. This is related to batch size property. So I'm going to specify producer config. All right. So, and if I want to specify, all right, batch size. So you can see that batch size configuration is there, and you can specify how much batch size. By default, I told you some 16834 number is there, right? So I'm going to specify 2000, 20,000. I can specify this many number of bytes I can specify. So you now got to know that, like, what is batch size, what is linger time. So basically, in order to buffer your data in asynchronous mode, all right, I can specify the linger.ms. All right, and what it's going to do here is it's going to it's gonna kind of like add some kind of like latency or some kind of like delay. All right, so that like I'm gonna get kind of like good throughput. So this is one of the property. Now the another property is, guys, synchronous and asynchronous mode. So guys, synchronous and asynchronous mode. Synchronous, what is the difference between synchronous and asynchronous? The one we have learned. Yes, can you guys help me? So synchronously, asynchronously. What does it mean? All right, answer is very simple, guys. Synchronous means you're sending a request. All right, you're waiting for some acknowledgement. Asynchronous means you're sending a request, you're least bothered about what is the acknowledgement. All right, so you're least bothered about the acknowledgement. So if you're least bothered about the acknowledgement and collection, guys, can I say it's gonna be fast? It's gonna be fast. Wonderful. So now, if I want to send my data asynchronously, let's say that your requirement is I want to have a high throughput. Sometime you want to push your data asynchronously. All right. Sometime, guys, ordering is very important. You want to send your data synchronously. All right. So by default, guys, the producer.send, guys, gonna send your data synchronously. All right. And if you want to add like send your data, so basically if I have to send Kafka data, I got two options. I can send synchronously. All right, I can send my data asynchronously. All right, and I can send my data async with, all right, this is kind of like optimized way, with callback. Want to send my data with asynchronously, but I got one interface available called Callback Interface. I can use that. So if I want to send my data asynchronously, guys, by default, it is fire and forget. All right, asynchronously, the other name you can call it as fire and forget. So if I call send method, guys, it's gonna act as a asynchronously. If you want to make this synchronous, guys, you don't need to do it based upon your requirement, guys. You just need to specify here get, and it's gonna send your data asynchronously. All right. So it's gonna throw some exception. So I'm gonna add exception to my signature. So now my data I'm sending here is in asynchronous fashion. Yesterday class we have seen then send record, right? Now guys, if you want to make optimized way, so I need to use asynchronous with callback. So I want some notification, but I don't want my Kafka to wait for that notification or acknowledgement. I want to have that notification from some other interface. So in order to do this, guys, you require to have a callback interface. So so this is the optimized way. So this is how you're going to write up in production. So new callback, I'm going to just click and it's going to pop up some of the piece of code, because callback interface does got some like abstract method called on completion. And what it's going to do here is it's going to give acknowledgement, or it's going to give you a future object name called record metadata. And from that record metadata, guys, I can access whatever I want. All right, so let's all right, let's have a logger factory dot get logger, and what is NSC producer dot class. So I have set up my logger. Now guys, I import my class. And inside this, guys, I can access any of my metadata. So logger, all right. So logger dot info dot, all right. So I can specify metadata info. So basically, guys, I can get anything out of it plus record metadata dot. All right, you can grab like which topic you want to write. All right, I can specify that. All right, so I can log this information. All right, so which partition you want to write it. All right, I can specify record metadata dot partition. So basically, it's going to keep a track of it. It's going to return a future object called record metadata. And from that, guys, I can access any of this. All right. So which offset my data has been written. So I can specify record metadata dot offset. All right. And I can grab all those information. So this is one of the optimized way of kind of like writing. So asynchronously will give you kind of like speed which you're looking. All right. So but like if I want to have kind of like some safety, all right, I can have this callback feature and I can grab all this kind of like performance. So we talk about linger.ms, we talk about synchronous and then synchronous, the first part of producer, we talk about it. So basically, guys, all right, we talk about compression, we talk about batch size. All right, wonderful. All right, now the next one I want to talk about here is like how to make your production server configurable. All right, so in production server, so basically across my Kafka side, guys, so you know that like there are optimization available three-way, right? So we have just discussed about the producer. Now we want to discuss about the broker. So how I'm going to get optimization across my production server, all right? So basically, guys, I require to have, like if you want to maintain your production server configuration, so if I want to maintain production server configuration in check with respect to optimization, all right, what I need to have here is these are the properties I need to specify. Very important property, guys. All right, I'm going to show you this num.replica.fetchers. HERS. So if there is a mistake, guys, we're going to find it out. All right, then you got like one more important with respect to production server called fetch dot max dot bytes. The other property what we got here is the replica dot socket dot receives dot buffer bytes. This is also one of the important partition. All right, and you have to pick always good number of partitions. So if you want to pick partitions, you can specify this. All this property, guys, it is kind of like broker side. So number of IO threads is also one of the property. Okay. So what is num replica fetcher? All right, what is replica fetch max byte? Number of partition, right? Number of IO threads. All right, and we will be discussing about this. Let's take a small break. Once we come back, guys, we're gonna understand about like this production server related configuration, right? Hey guys, I'm back. Hope everybody's back. So one of the important thing, guys, how you have to configure your production server, right? So I got like one of the property called num.replica.fetchers. All right. So this property will tell how many number of threads you require to replicate your data from leader to follower. So imagine that. I've specified replication factor as 4. So as per our discussion, guys, we know that 1 is going to act as a leader, right? So leader is 1. The rest of the stuff you can call it as followers, or you can call it as ISRs in sync replica. So if I specify replica as 4, 1 is going to act as a leader. So the controller node going to pick one of the partition as a leader partition, and rest of the 3 as guys it's going to consider as a followers or in sync replica. Now guys, all your read and write operation is going to be happen with your leader, right? So leader is going to write, later on it's going to replicate. So if I have 1 leader and 3 followers, guys, minimum, guys, all right, you have to allocate based upon your replication, guys, how many number of threads you want to copy your data from leader to followers. All right, if you specify less value, guys, I'm going to lose the parallelism. So always provide more IOs, or at least minimum you specify how many replication you have. Based upon that many number of thread you can specify as a num.replica.fetch. All right, so num.replica.fetch is going to give you a thread which is going to help you to copy your data from leaders to followers. That's how things going to be replicated. Now another important property with respect to replica, guys, the parameter replica.fetch.max.bytes, all right, is about like how much data you want to fetch from any partition. So how much data you want to fetch from any partition in bytes, guys, for any particular fetch request, right? So it is good to increase this value for this parameter, so that help, all right, create replica faster in the followers. So basically, guys, my leader has to replicate my data across my followers. The first property will tell you how many number of threads you want. All right, let's say that I got 3 threads. So each thread has to copy your data. But how much minimum amount of, or like basically how much data you can write it in every, right, every action from leader to follower, guys, how many bytes you want to write at once. So if I specify more bytes, follower will updates very faster. So it is good to have this maximum bytes data, like a good value, so that it's going to faster its replica. Now another one is also kind of like replica.socket.receive.buffer.bytes. This is also one of the property. All right. It is related to buffer. So you know that like all your batches is going to be created inside your buffer. So buffer is nothing but a place in the memory. All right. So before sending to your data to a producer, guys, I can collect all my data across my buffer and then send my data across like that. Now, if I increase the buffer size, all right, increase the buffer size, definitely it's going to give me performance. Now we can increase the size of buffer, all right, if we have less thread available. So if I don't have many IO threads available, guys, I can increase the buffer size, all right. And in case, guys, if your replica thread is like little slowly writing across your followers, all right, increasing buffer size is gonna kind of like handle more incoming requests. So it will kind of like not a very big load on top of your Kafka broker. So buffer is always important property, guys, if you want to increase, you're gonna get. So based upon like available system buffer. Now the num partition, guys, partition is the only way, guys, you're gonna get a parallelism across your Kafka broker, right? So your entire topic is divided in the form of partitions, all right? So, so we can have a level of parallelism in terms of read and write your data in parallel, all right? So automatically, guys, if I have more data, more partition, guys, all right, many threads are writing your data across different partitions. Automatically, guys, all right, if somebody wants to consume your data, all right, consume your data, still it is not a problem because we got like more partitions available. So automatically, guys, it's gonna increase the throughput, guys, if I specify number of partitions for a particular topic as 3 or 4 or 5. So, however, guys, if you have a situation, your Kafka cluster does have like very less computer, and if I specify too many partitions, guys, definitely it's gonna slow up my process. All right. So you have to select an optimal value between your throughput and latency. All right. So if system does have like enough backend threads, IO threads available, guys, you can increase the number of partition. If I have a single disk, guys, all right, doesn't make any sense. All right, so I can have kind of like less partition. And another very important part, guys, number of IO threads. So you know that like writing your data across your leader to follower, you require threads. All right, right. If you want to, if you want to do any operation, guys, you require IO threads. So how much disk we have in our cluster, right? And how do we set this IO threads, right? So basically, all this IO thread is useful for kind of like making a request, all right? So hence, number of threads, guys, gonna yield you more performance. So better, better processor, guys. Good number of IO channels, I'm gonna get it, and good number of parallelism, I'm gonna get it. So IO operations, I can increase by having kind of like increasing the number of threads in case if you have threads available. So these are kind of like properties related to broker. Now in consumer side, guys, I got few properties. Let me discuss consumer configuration. Properties. So these are kind of like deserializer, value deserializer, all this are property which we have learned. All right. Out of which, guys, if I want to think about so fetch bytes, all right, minimum fetch byte, maximum fetch bytes, this is gonna yield you performance. So if you want a kind of like parallelism across your consumers, guys, across your consumer, we have talked about a concept called consumer group. All right, consumer group, I can create a multiple consumer instance to read my data across my Kafka. So I can create a consumer group. So group ID is kind of like one of the way we're gonna get a parallelism, and it's gonna do the performance optimization. It's going to do the performance optimization by carrying the same consumer application with a multiple consumer threads. Now I got like some of the property like fetch min bytes. So this is also very important, guys. Fetch minimum bytes, as the name says, how many minimum amount of data I want to fetch from my Kafka topic. All right. So if I make a request to my Kafka, all right, it should return some kind of like it is a fetch request. All right. So if I make a request, guys, now sometime I may get like very less data. All right, very less data. And like let's say one record I got it, or 0 records I got. Now, if I specify fetch minimum bytes, my consumer will wait till he gets this minimum amount of data. And then over a period of time, guys, it's going to write a request over there. So this will add kind of like performance. All right, so I'm not kind of like utilizing IOs, all right, with the minimum amount of data. So I'm specifying, okay, this is the minimum data I want. And this property should be kind of like always greater than 1. And you got the similar property, guys, max partition fetch bytes. So the maximum amount of data per partition of the server will return. So if you make a request, guys, to your partition, how much of maximum data as a part of request to response, it has to kind of like get. All right, I can specify this property in the topic configuration, like these many bytes of data I want. So fetch max bytes. All right, I can specify maximum message bytes as well. All right, always specify your session timeouts, guys. All right, like 10 seconds works very well. All right, so these are kind of like properties you have. So important property with respect to optimization, guys, group gonna give you a group ID, gonna give you like allow you to run multiple consumer inside one group. Second property, what you got here is the minimum and maximum fetch bytes, how much minimum of data you want to get from your request, or from your partition, guys, how much maximum bytes you want to read, right? All those are nothing but with respect to optimization. All right. So that's about performance and optimization we have seen across like producer, consumer, and broker. All right, guys. So any question, guys? Any question till now? Let me know. We're almost done. All right, so I got a message. A very big question. Hi, Pavan. Kafka topic with single partition. I have log retention for 10 minutes. All right. Placing produce 10 messages so that offset number 0 to 9. I have a node service as consumer. It is consume all 10 messages. Very good. Now I am give me 1 second. Some problem with the Zoom. I'm not able to read. If I start node service waiting for the offset, then all the consume message are the loss for new message which have offset 0 to 9 also not coming. How to handle either we need to increase log retention time or any other solution. Okay, give me 1 second. So I got a question, all right, from Selva. He said, all right, I got a one Kafka topic with a single partition. And he has specified retention.ms time as 10 minutes. So place or producing 10 messages, so offset number from 0 to 9. I'm getting it. So he get kind of a 10 messages. So it's definitely one partition. So all your data is going to be written in 0 to 9. Very good. So consume all 10 messages. Now I'm stopping the node services. Okay. I'm placing another 10 new message in the same partition, so that offset of 10 to 19, I am gonna get, all right. So node service not consumed yet. After 10 minutes, the message in Kafka detected due to log retention. All right, that is also right. Also offset is reset to 0. So if I, after 10 minutes, if I start the node service 0 to 9 also not consuming, how to handle this? All right, you have given the solution. All right, you have to increase the retention time. So Kafka Kafka will kind of like keep all these messages for a specific period of time. So if you want to handle those kind of like messages related to that particular topic, which is uh, dependent upon the retention time, all right. So all you need to do here is you have to increase the log retention time and keep the data till there. Then only you're gonna get your data in a correct offsets. All right. Otherwise, it's gonna kind of like reset to 0. All right, no other solution, Selva. This is how you can do it. Your data will not be there if you don't specify proper log retention time. You can commit your data, all right, whatever data you want to commit, but all right, if you want to access those data has to be there in Kafka, right? So log retention.ms property will delete your data for that period what you have specified. So any other questions, guys, before we go? So in this short span, guys, we have learned a lot of things. I know that this is not sufficient time to learn entire Kafka, but I have tried my best to make you learn as much as possible, guys. But usually, if you want to learn Kafka, it's going to take kind of like 30 to 40 hours. But whatever needed for the production, guys, all right, at least you have learned the basics. And now, if somebody give you some code, you will be able to understand those codes. All right. So here is the feedback link, guys. Oops, I've sent it to only Selva. Let me send to everyone. All right. So this is the feedback link. All right. So you have to fill this feedback form. Right. You can specify about this training. All right. Right. And if you like the training, you can go with 5. If you feel something is missing, you can go with 4. If you don't like the training, you can pick anywhere like between 0 to 4 or 1 to 4. All right. So you can specify all those information over here and you can submit it. All right. This is a mandatory thing you have to do it, guys. Yes, this is our last session. So any other questions, guys? Any other topic you want to know about big data, artificial intelligence, Kafka, any big data related technologies? Yes, you can ask now. So how many guys are fresher here? How many guys are fresher? Just started working, half year, 1 year experience. Kaliappan is a fresher. Thirban is a fresher. Okay. And only 2 freshers. Sanket got 2 years of experience. Okay. Right. So the idea is, guys, now if you read any Kafka documents, guys, all right, you can understand almost like every advanced concepts as well. All right. So 6 hours, 7 hours, we cannot make entire technology, but now you got a capability to understand the core parts, all right, very easily. All right. Kafka is very beautiful subject, guys, and very much useful in production, guys. Right. It is a must-have technology if you want to work with the real-time environment. Almost like 99% companies uses Kafka if they want to deal real-time data. So this technology gonna stay for long, very long. So it is good to kind of like master this technology. All right, guys. All the best for your careers. All right. It was nice teaching you guys. See you in some other course. Did you guys fill the form? Yes. Can I get a quick confirmations? Yes. Okay. Super. All right, guys. Enjoy your rest of the course. Till then, see you. Bye-bye. See you soon. So you guys work for NSC. Have you kind of like made your portfolio, stocks portfolio? I was just kidding. All right. See you then, guys. Bye-bye.